Okay, welcome back everyone to another Serenum stream. It's been way too long since I last did one of these. But that's what writing grants and founding companies and all of this stuff involve. Okay, so for a while I've been wanting to experiment with the Serenum graphics and actually get into programming these graphics in like RISC-V. In the game so far, we've just drawn everything using rectangles. However, those rectangle procedures were drawn by writing a bunch of assembly. And so I want to first examine that today, and then let's see if we navigate to our second one, and then to basically start playing with that, because eventually for this game I want to give it as decent as graphics as I can. Like, I don't want to spend a huge amount of time on the graphics, but I do want them to look better than what is currently here, which is this. So like maybe this will just involve just making like the tiles better in some way. Oh, hang on, my stream seems to be stuttering a lot. I don't know what's happening. Why is the internet suffering so badly? Okay, since this is going on YouTube anyway, actually I should also post to, I forgot to post to Discord that I'm streaming. Oh, we want to do this one. Since this is going on YouTube anyway, if the streaming quality is really bad, I will think about this. But yeah, for the moment, this is override. For the moment, we'll continue as usual. Okay. Anyway, yeah. So I wanna enable myself to make these graphics better, but that will require figuring out how to make them in this operating system, and it will be a good excuse to familiarize myself with RISC-V again. Okay, so I think the first thing to do is to make another separate project, which is just like drawing a rectangle, something very simple. Okay, I see rectangle drawing example. I slightly remember doing this previously. Let's check out what we did. So I guess we drew a checkerboard. Uh-oh, why is this? Okay. Sure, this looks fairly simple. But it looks like I'm rendering in 180, so I'm getting like a pause. Let's also open up a new tab. How do we do that in this operating system? Yeah, it was in this like tutorial. These things were mentioned. If we do like F1 one dot text. Oops. Can I just do cat? No. Maybe it was a typo. Okay, that was correct. Caps and enter, okay. That's right. But oh, shit. Well, that's right. I think it was like caps lock 2 to open it. Yeah, that's right. Okay. All right. So we'll make this one the thing that opens the windows, and then we'll move the editor in the first tab. So yeah, leave this one here. And then tab 1, we want to, is it just literally, yeah, it is. Let's check out the source code for this. So I think we want to do, all the source code will be in the codex. And we want to do script or, this doesn't feel correct. I think it's just script or checkerboard dot libc. Wait, not libc. Like, oh no, what's the Elgato doing? Okay, here it is. Like, since I'm at a new place, I haven't really done any like the internet configuration or tests. So I can just see on my iPad that the stream seems to be stuttering in some way. Anyway. Okay, so what in here is actually drawing the rectangles? And then how can we begin to modify that? So we've got two DOM loops here, and it's just noob rectangle. Okay, but where is noob rectangle located? It must be in one of these. I suppose we can just check out each of these one by one. So we've got procedure imperatoris, basis arena, and regestio. I would doubt if it was in this one. So let's start off with like the regestio and then work our way around. I guess we can quit out of this one. So yeah, regestio, basis arena, and then procedure. So yeah, so we'll go into the fulcra, and we want to do script or, and when we're not modifying any of these, so we're opening them read only. Let's check out this regestio. Okay, yeah, it doesn't look like it's in here. Yeah, so this is this like a general this is like this Ruggiero function we've called a couple times. Okay, so this is literally just the entire file for printing things. Okay. Okay, let's try the procedure and protors. Give this a go. Maybe it is in the basis arena. Okay. Alright. Let's try it out. Okay, yeah, so there's a lot of disparate but important stuff in here. Like reading entire files, the graphics, okay. Okay, so here is the drawing stuff. Okay. New draw rect ASM and new rectangle. Okay. Yeah, I want to read this and understand how the drawing's actually happening with this. Then I'll likely want to copy this, move it into the, you make a copy of this, set up a new project, just put this inside the source of the project and then start tinkering with it, and then we'll start drawing stuff. And we can really draw some basic things, like let's draw a circle or a disc. A disc would be easier using assembly, or a triangle, kind of hard. We'll see, we'll get to it. Reading this first. So yeah, the rectangle drawing function takes in the kind of frame, XY coordinates, width, height, and then the color. And then, yeah, this is just to like make sure the inputs are sensible. If they're not, quit the procedure immediately. Otherwise, well, it's rather, yeah, it's just, if the rectangle is too big, don't bother. Yeah, if x and y are negative, set both to 0 and set the width and the height to 0. Okay, so all of this stuff is just making it sensible, and then the actual drawing stuff is so call this ASM, this assembly, with let's see, with frame.pixels is presumably the array of data for the frame. Then cast to a pointer. why are we casting the frame width to S64? I guess we do it. Like, why are we multiplying this like width by 4 here? Let's read this and then figure out what arguments are being moved into it. But it's all like, we're still getting the width and the height. It's just the base and the stride here that are getting adjusted. Like, we're saying the stride is 4 times the width, which, and could the 4 refer to like 4 bytes used in color, maybe? But what's this base? Hey Sam. I see the multiple by 4 is due to 4 bytes per pixel. Yeah. It's good. Yeah, just the sensible regular color format that everyone knows. Okay. So yeah, let's do. Yeah, this part here is like the stuff that I want to do tonight. Like, it's been way too long since I did any RISC-V programming, and so it's fun to use a programming language and infrastructure that is sensible enough that I can just do this immediately, and I don't need to import some like binding library to like do something fancy. Like, when I've tried to do intrinsics before in, I think, even C and C++, I just couldn't actually get anything to compile. I was very sad. And then with Odin, I think they were introduced but then taken out. I haven't checked them out in Zig, but I want to do them now with your language. Okay. So yeah, vset vli. I'm trying to remember, like in RISC-V, is like what's the order of the registers again? Is it like, do we write to this one and then we're taking these ones as input? Or is it the other way around? I'll figure it out. It kind of would be easy to look up online. Yeah, the non-vector instructions have the most coverage. Okay. So yeah, MV is move. Sub and add are obvious. As is ret. I think B and E is like branch if not equal to. What's the difference between add and add-I? I think, yeah, add-I is when you're using a constant. Okay, so it must be, the very first one must be the register we're writing stuff to, and then the last two are the sources. Okay, so this is simply saying like add 1 to register 7. And then yeah, this is just saying if A7 and A3 are not equal, jump to draw a rectangle ASM while loop. Oh, okay, this actually isn't like the most bottom level. No. This is fine. This is just like a tag in memory. Okay, it's just this. Okay. Okay, so S2 is the. Oh, this is like a great memory, back to memory lane. So what's the calling convention for RISC-V again? It looks like A0 is the pointer and A2 is the counter. I might have to look this up with a reference. Well, but do I actually need to do that? Yes, because I need to know how function arguments that I pass into, procedure arguments I pass into Brevis are going to end up on the CPU. Okay. So let me move my iPad so I can see your comments more easily, Sam. There should be space. Like I ordered in another monitor, but I'm still waiting for it to come in, so I have like the weirdest setup. I'm actually just using my TV at the moment. And I'm enjoying doing this programming on this big 4K screen in front of me. There's wires everywhere. Okay. Yeah. It's destination, argument 0, argument 1. Add I is add immediate, that's right. Okay, Brevis calling convention is mostly like the C one, but there are some exceptions. Yeah, arguments at A0, A1, A2, etc. up to S8. Yeah, I think I remember something like that. But then there's like the question of which ones do you have to save to memory? Which registers are like allowed to get overridden and which ones cannot. Yeah, you want to look at the RISC-V spec PDF in the CRA folder in the Serenum source. Oh, great. Okay. Okay, that's good to know. I feel like I should just look that up now and bring it on the screen. Okay. Okay, so let's say we just go back to this. Okay, let me bring up the RISC-V spec. Okay, so Windows. You don't have to just black out when I switch between things. Okay, so let's see. I think it would have been in the Serenum backups if I backed up everything. There's an easier way to do this. Let's just search for PDFs. Okay, let's see. Oh yeah, there it is. Okay, so there's a more recent version. Okay. Oh yeah, upstream CRA RISC-V spec. Upstream CRA RISC-V spec. Okay. What's the difference between these two? Oh, that's the vector extension. Okay, this is like the main one. Okay. It will be good to have. I feel like I'll have to look at this at some stage tonight. Oh yeah, this is bringing back memories. Yeah, like I remember that it was before you get onto the extensions. Like without the extensions, the core is still the core is quite manageable. Like it's, yeah, like at the very base, it's like page 13 to page 29. I mean, that's a reasonable specification that someone can read in a day and understand most of it. Okay, but yeah, which version are we using? If I search for handbook, oh, very nice. Great, this full screen. How do I make this PDF reader full screen again? Control Shift down. No, I don't want performance logging. Oh my goodness. Like AMD, what are you doing? There's no one at AMD use Sumatra PDF reader. Like, come on. Okay. I guess they all use Adobe or something. Okay. Yeah. This is right. Oh, this is great. Yeah, this is exactly what I wanted. Oh yeah, you can use this to like zero out things in instructions. No need for like XOR. like what's the x80 thing, the x86 thing? It's like XOR R8 to make it 0. Like no, you can just do this in RISC-V. Okay, always the return address, stack pointer, the global pointer, the thread pointer. Okay, yeah. Okay, 10 to why isn't the specification allowing us to return more than 2 things? Interesting. And yeah, I feel like when I last programmed in RISC-V, I wasn't using any of this floating point stuff. I guess I could learn that if needed. That's right. All of this stuff is temporary. Okay. This is good. It's all important to know. Okay. So then, if we go back to this stuff. Okay, yeah, totally gonna have to look at some instructions. Okay, I think I understand all of the base ones except the vector stuff in this. So yeah, all of these ones, I think it's fairly clear what's, like I know what all of those now do. This one is just branch if it's not 0. Or if it's not equal to 0. Ooh, what's this? SLLI. Okay. So there's only a couple I need to look up. VSET VLI, VMV. Maybe it's best to like toggle off the full screen in this case. How do I do that? Can I like projector. Okay. Okay. Let's just start at the top. So this v set VLI. V set VLI. Oh, okay. Not in that one. So then in this one. V set VLI. Provided to allow rapid configurations of the values in the this should be an L, right? VL and V type to match application needs. Okay. I wonder if I need some more background before even reading this. Yeah, I might just want to just skim the first couple, the beginning of this. So it's a draft of RISC-V base, okay. Each hot, okay. Okay, so we get 32 vector registers, each with VLAN. Like, what's VLAN in this case? The maximum size of a single vector element in bits. Okay. So like 64-bit or whatever. I mean, this part's obvious, okay, but it has to be a power of 2. Okay. So yeah, like no vectors with 3 elements in them. Okay. What's this striping distance? Okay, so ELAN is just element length, VLAN is just vector length. Okay, in bits. Okay. So yeah, the registers have VLAN, no surprise. The read-only XLAN wide vector type V type provides the default type used to interpret the contents of a vector register file. Okay, so what's the layout? Okay, so some like tracking, all of that's 0. Oh, curious. Multiple vector registers can be grouped together to form a vector register group. Okay. Okay, so I think we're doing. I think we have a 64. I think VLAN is 64. Okay, all of this stuff. The instructions in the vector extension fit under 4 existing opcodes. Oh, okay. Load floating point, store. I don't know what AMO is, and opv. Okay, now we're back here again. Okay. Yeah, so we're saying set, I don't know why that's indented. So we're saying set VLI S4 A2 E32 M8. So what are one, where do these arguments come from? Surely this is just like the values of the base stride. Oh, no. Yeah, so already I'm slightly confused. That set VLI here is taking in 3 registers, but there seems to be 4 here. And yet, of course, it works and compiles. And then there's VMV. Don't know what that is. VMV. Oh, maybe this is like a standard notation. So vmv.v.x, what does this mean? VMV, well, that's it here. So this is saying it sets the ith element of VD to RS1. Okay. Let's see. Vector integer merge combines 2 source operands based on the mask field. Like regular arithmetic instructions, the merge operates on all body elements. Okay. So yeah, the I here is just like referring to all of them simultaneously. Fine. So in other words, this is just saying make a constant vector where every entry has RS1. Okay. So yeah, set everything in V8 equal to A4. All right. And then the operation is masked, VM is 0. So like, how is VM influencing these? Like, how do you even control this VM? Like, what even is it? Is this VM like part of this setup? Like, I don't see it here. We'll figure out how exactly what this is later. So the VL is referring to this vector length. I'm surprised vstart isn't 0. Okay. So yeah, whenever VM is 0, the instruction combines two sources as follows. At elements where the mask is 0, the first operand is copied into the destination element. Otherwise, the second operand is copied to the destination element. Yeah, I don't see how that's applicable here. Okay, that's why it's like VM's 1, since it's not applicable. Okay. But for these ones here, so vmerge requires this. What's like VMV stand for? Vmerge is clear, but I guess it's just, it must be vector move. Okay, so yeah, so it's just like, now I'm getting it. So like vector move VI is like saying move an immediate into all of the vectors. This is like, I'm liking this naming convention. This is like, it doesn't take that long to understand, even when someone isn't like explaining it to you, and it's kind of, okay, I like this. So yeah, move into vectors an immediate, move into vectors like a single element. Oh, and then like move a vector to itself. That must be, great, okay. So just like, use this for copying vectors, use this to set a constant vector from a register, use this to set a constant vector from instructions. Okay, great. Yeah, so we're setting like V8 here to be equal, like a constant vector V8 to A4. Still unclear what this set VLI is doing. What does li do again? This is like a really common instruction, I remember that. Let's see, like li. Is it load space li space? There's a better way of navigating this. Like, where's the instructions and what they say? That's what I want to know. Okay, they're in here. Oh, that's right. Yeah, I remember this is coming back. Like, I think some of these are arithmetic, some of these are memory, and there's others. Then there's like some weird versions as well. Yeah, okay, blah blah blah. So the arithmetic ones are, what type of, okay. This is an unnecessary rabbit hole, but it's the li again. JL is jumping link. I feel like it stands for load immediate. Like it's... Like it has to be in here, right? Like why can't I see an explanation of the load immediate in here? Yeah, okay, here it is. This is what I wanted, I think. Myriad sequences. Is that all it is? Oh, what does this do again? Like how do you control what it's loading? Okay, there is this like sample program we could read. Okay. A sample code for compare and swap. Okay. Memory location A0, A1 expected value, A2 desired value. Okay. Return 0 if the expected is the desired value, otherwise whatever. See, this like load immediate is like, oh that's right, yeah, it's the same as like the sub-I or the add-I. You're just moving a constant into the thing. Okay. So then, yeah, the li here is exactly this. So set, it just means set a7 to be 0. Okay. Well, no. It's saying set set the memory to pointed by a7 to 0. Right. Yeah. No, it's just setting the register. Okay. It's not doing like, it's not following. Yeah, it's literally just saying set this thing equal to this. Okay. Look, I'm kind of wondering why this instruction here isn't like the move x0 register into a0 and just 0 it out, but okay. In the context of all of this, it makes sense. Okay. 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 Yeah, so let's see. I seem kind of like frozen, which is, no, that's fine. Is Twitch being annoying? here's another one, this vsc.v. So vmv is vector move, so this is presumably vector subtract. And then using this notation, it should mean subtract. What does this bracket mean? Is the bracket like dereference the memory of that? Like this is holding memory, dereference that, and then subtract that result from everything in V8. I think so. Okay. So yeah, the only thing kind of, okay, remaining is this SLLI. This doesn't look like a vector one, but I don't remember it. SLLI. What is this? Performs logical left shift of the value in RD, then writes the result to RD. Oh, okay. But where's like the usual, like? Yeah, logical left shift. Zeros are shifted into the 0 bits. Okay, so it's just, we're just like multiplying by powers of 2 by alright, and then it's like logical shift left immediate with the I. So we're saying yeah. So it's just multiplication by 4. That's all it is. Which makes sense. And then okay. So yeah, the only thing left is this vset VLI thing. I still am fairly clueless about what that's actually doing. Vset VLI. What is this? So it's just like, what's the internet like in this? This is Australian internet for you. It's a disaster. Okay, so knowing these are setting configuration values, we're now saying the RD is the new VL. Okay, but the vector length is always 4, isn't it? So, or not, okay. Don't know what the AVL is. V-type I is new V-type setting. Okay. What do I want to do? I feel like I don't want to have to like check, like figure out what this like, what all of these this V-type stuff is. Like maybe we should. I want to just like try and see if I can just like leave it kind of how it is and just modify stuff for fun. Like what's xlen? Like ELEN was like the length of the element. VLEN was the total thing. Like what's like I'm yeah, like xlen is this U thing. What is this? What is xlen? Is this not defined anywhere? You've got to be joking. Please. At the very beginning of the document, you defined what VLEN and ELEN was. Why is there not like an xlen anywhere? This is frustrating. Like it appears here before it's even defined. like what? Who wrote this? Who made this? Do I need to submit a pull request that people define this? Like I could just be missing it, but I don't see. Like here's the definition of the ELAN, here's the definition of VLAN, and suddenly this just appears out of nowhere. What? This is annoying. What is xlen in RISC-V? Oh, I didn't mean to evoke the LIM. Oops. It's the width of general purpose registers. Okay. Okay. So maybe it's actually in this stack. Okay, it's in here. Maybe that's my bad, but at the same time, would it be really hard to just like mention it again in the specification? Anyway, back to the V type. I forgot what page it was on. Oh, it's here. Okay. Okay, so the final bit of the register is a legal if sat. Multiply setting. Okay, this is what I wanted to know. Okay, there's 3 fields. Illegal, which we don't care about, VSO, and VLMOR. Okay, VSO is just 2 bits. Standard element width setting. Okay, and then VLMOR, which is what? Vector register group multiply setting. Okay. Okay. So For the vset VLI here, let's try this again. Vset VLI. This was on page 55, wasn't it? No, 55. No, it clearly wasn't. Oops. Yeah, so I'm seeing these again. What's this AVL? Required application vector length. Okay. So presumably that's like 4. But like it's, yeah, this is what's like troubling me in this, is that it's not like, there's some variance in how I can do this. Okay, in either case, I've done enough vset VLI stuff for now. So I want to just think through generally what the procedure's doing again. Yeah, so the very final argument that's getting called is 4 bytes, that's the color. 8 bytes, that's the height. 8 bytes, that's the width. Yeah, 4 times the width of the screen. And then for the pixels, what's this? We're offsetting the pointer to the beginning of the array by this kind of X and Y. Okay, I think I see what's happening here. So we just want to like zoom to the first pixel. We want to zoom to the index of the first pixel we're actually going to change. So if we're drawing a rectangle beginning at coordinate X and Y, then yeah, like how would I do this? Yeah, you want to like jump down by Y. You want to jump down by like the width of the screen times Y, and then just add on the X. So then we need to multiply that by 4 because all of these are bytes. That's what that's doing. And then yeah, this is exactly what's happening. Yeah, multiply. Okay, totally understand that. So now for the very first argument getting passed in here is the place in which to like the location of the byte, the first byte that you want to, like the location of like the red pixel, like that you want to start modifying. Okay. But curiously, like the stride is here. Okay. So yeah, so Sam says we configure the vectors, then fill V8 with the color. Okay. sure. Right, since A4 is, yeah, if we're, so maybe this is the part where I was confused. I thought for some reason that the chip in the Serenum has registers that are 64 bits wide. Maybe I'm just thinking of some bad extension. So I think everything in RISC-V is just like 32 bits, right? Yeah. Yeah, they are 64 bits. Okay, so yeah, so now I'm confused. Okay. Just like if each of these colors is 32 bits, and we're like I'm not quite seeing how V8's getting filled with the color, because like I thought this .x extension here means like make a constant vector where every element is the thing we're filling in. And so I guess like if A4 holds the color, which I guess from the calling convention it would be, if like A0, A1, A2, A3, A4, we're then like making a vector that's like constant colors everywhere, and I'm kind of confused as to why that's happening. Oh, okay, X is a general purpose register. Okay. I see, yeah, if the vector is configured just to have 32 elements, then we choose the lower 32 bits. Okay. Yeah, I wondered if that had to be specified or not. Okay, and then E32 in vset VLI is for 32-bit elements. Right, okay. This also explains why there's only 3 arguments in here, but there are kind of 4 arguments in this one. Okay. Okay, so I guess I just didn't scroll further enough down in this. I didn't realize the instruction was like overloaded in some way. Jump to here. Maybe if I search this for like the vset. vset VLI. Oh, I see, yeah, based on 32-bit vectors. But if we want to do the 64-bit version, here it is. Okay. Oh, this is great. I didn't realize the documentation had so many examples like this. Oh, this is incredible. Okay, I think I'm just going to read this now. Okay, and hopefully this should just help me understand everything. Okay. Vector add routine of 32-bit integers. Okay, so in C code, if we're saying define VV add int 32, and we pass in some positive integer n, pointers to integers x and y, and then z, which I guess we'll modify. Yeah, set the ith element of z to the corresponding thing. Okay. So yeah, A0 is by the calling convention. A0 will be n. Like what was the where's the like handbook is what I want to show. Wait, what's like, I forget, like is the A0 like an alias for something? I feel like it should be. I've forgotten what these like what the A0 stuff is. Can I do like AI? No. A1. I'm like going down a rabbit hole with back. It's what was it again? Yeah, that's right. Yeah, A0 is an alias for X10. Yeah, I remembered. I forget exactly which one. Like, is this it here? Like, is this saying that? Like, this bit here kind of threw me. Oh, I see. This one here is that one. Yeah, I see. Okay, so if I ever need to use these floating points, it's good to know these are the corresponding aliases as well. Okay. Okay. So yeah, register 10, 11, 12, 13 is set to NXYZ. And then yeah, here's the all-important vset VLA. Set vector length based on 32-bit vectors. Okay. The second argument is the n, which is the length of the vector. That makes sense with regards to here as well. A2 is just the width. Okay. Oh, so curiously, if a rectangle gets drawn and like the rectangle is like 200 large, we're literally saying like make a vector with length 200. Okay. Curious. But yeah, I guess there's no reason why that shouldn't work. Okay. And then what's this T0 doing? Yeah, what's this T0 and what's this E32 doing? So maybe E32 is like another alias. It's not in the base, curious. Okay, but I mean, is this just an alias for a constant? Or does it need to be set up? I'll just take it as a given that it's E32. Okay. Okay, so I understand the second and the third argument here, and then there's this S4 and the M8. Okay, which is here like the T0. This is like we'll have to jump to like the non-32-bit vset VLI for this. Okay, and what's this M doing? We'll come back to this. We'll come back to the full document. Okay. So yeah, vector load. Yeah, look in them like this is A1 holds memory, dereference the memory, set a constant vector V0 equal to that. Fine. I guess like another question is like where actually like what registers like what's V0 like which registers actually hold this? Is there another table, handy table I can do this? Like I doubt they would be. Possibly they just could be different hardware. So yeah, the return value of vset vi gives you the amount of elements you actually got because the vector size is unknown. Oh, okay. Like is the V0 is if V0 is an alias, I don't want to like stomp over stuff without knowing. Like a simple version would just be to read through all of this, but I'm like, yes. Let me just pick it up as I go. I feel like diving in is the best way to learn something anyway. Okay, so back to this one. Who knows where V0 actually is, but let's just assume for the moment it's not stomping over anything. Yeah, load x set V0 equal to constant x everywhere. Decrement number done. So like why are these indented? I guess it doesn't matter. What's happening? This I understand. Bit unclear why we're storing them in V2. I guess it's just another register to use. Why is A... Okay, yeah, A3 is the return since... That's what we're doing. Ooh, but there's all of this like... Extra... Okay. So like, yeah, all of these instructions, it's clear what's going on. Everything else, I'm not sure. So yeah, set set v0 to be x. Oh, but it's like it's not actually setting it to be constant though. I see. Okay, yeah. Now I truly understand why this is important then. Okay, yeah. If we're not setting v0 just to be like a constant vector, then in order to like even make this copy, we need to know how many bytes are getting copied, which is what this thing's doing. Yeah, so we're saying set the vector length here to be n, so that we can literally just copy like the n entries of the data that's at A1 into V0. Okay, likewise do the same thing over here. Add them together, store it in V2, and then save it. Okay. Everything else, a bit unclear. Decrement number. Okay, so Sam notes the V0, V1, V2, V3 are actual vector registers. Okay, great. And then yeah, VLW.v is load vector of words. Okay. And then okay, so the W is actually referring to the bit width. Okay. So vector load W dot no, it's just this is just the vector version of the LW instruction. Okay, yeah, the W, it's just like with those like x86 instructions where like the letter in the instruction is like tells you like what part of it is. Okay, that's always annoyed me, so I'm glad that's okay. I thought that was what's going on, it's not. Especially when it's like move like the last two bits of like this x64 register to somewhere. It's like no one, it's not 1970 anymore. Okay. Okay, and then yeah, so what's this sub SLOI and add doing? Decrement number done, multiply number done by 4 bytes, bump pointer. Oh, okay. Wait, what? Okay, now I'm getting this T0. So like is T0 just one of these regular registers? I feel like it is. I think T stands for like temporary. What's like, it's an alias of something. No, what's it the alias of? Oh, it's not in here. Oh, wait, is it actually just a general register? Oh, it's here. Okay, it's okay. X5, X6, and X7. Okay. So T0 is just X5. Okay. Yeah. So I'm saying, yeah, you load stuff into the vector, then you need to advance the pointer by the amount you loaded for the next loop iteration. Check the handbook. Okay. Yeah. I guess like I'm almost surprised that some looping is happening here. And then I thought that perhaps like the instruction, like the ISA would make it so that you kind of can just like add loops, add vectors, but without needing, like you would only have to do this, and this, and that would be done. Like there wouldn't actually be any need for loops. But okay. Let me see. So here we're subtracting, I think from T0, which is the n, like like to me this looks like subtract n from something. Multiply number done by 4 bytes. Okay, and then bump it up. Like it's unclear to me why there's like a decrement. Yeah. Maybe this example will clarify things. This itself looks complicated. We might come back to it. Okay, mem copy. This is easy. So yeah, in the usual way, we're saying if we want to copy stuff to there from here with n of size t, whatever that is. How does this work? Okay, duplicate the copied destination to A3. Then we'll have a loop that we're going to be coming back to. Instead of E32, it's now 8-bit vectors. Yeah, store this thing in T0. That's what it seems to be. We're loading in here the n. Then this MA, like yeah, what does this MA stuff do? Oh, it's another like constant, presumably. Oh, so I guess this says suggest to assembler names because this is still a like it hasn't yet been like accepted by the community. Okay, but it is going to be a constant. VL multiply A. Okay. Okay. Oh, that was not. Okay. What's the difference between LB and LW? Anyway. Load bytes to the 0. Okay. V0 is just a separate register. Yeah, so load like the n bytes at source to V0, okay. And then like, yeah, now this like weird stuff happens. So now we're saying, yeah, I'm gonna like ignore reading all of this to begin with and just the stuff. Yeah, copy n bytes at A1 to V0. Then, oh yeah, SB is like the save bytes, your store bytes. Then move it to A3, okay. Okay, that makes sense. So then what's all of this stuff doing? Why do we need to bump this pointer and decrement account? Like this is happening in this code, isn't it? Yeah, like in between all of like the vector stuff. It's like all of the sub and the adds and everything. Okay, the decrement is for exiting the loop. Okay. For sure. Okay. Yeah. Continue looping provided it hasn't reached 0. Great. And then, okay, you say what the ISA does do is that on a future machine with wider vectors, the code automatically expands to use those wider vectors and will have less loop iterations for the same data. Okay. Interesting. Okay. Yeah, that's good. Like, yeah, we wouldn't want to like duplicate the number of like duplicate by like some power of 2 the things that are going on in that case. Okay. Oh yeah, so this we're like so yeah, I guess the only time we kind of use A2 in any of like the vector calculations is where we set it here. And then from this point on, right, like A2 is absence from here, A2 is not present there. So we can simply use this to decrement, to like keep track of the loop, okay. And that's all that's happening there. And then for the A1 though, there is like a data dependency here. So what's going on? Yeah, we are bumping the pointer. Why are we bumping it by T0? Like T0 is the thing that, like I'm kind of thinking of like yeah, what should it be? Like it should be the number of, like shouldn't it just be the size of like these vectors that we're copying? Yeah, like if this calculation here is just m8 times like n times 8, then we get like the total number of bits. And so for every time that we copy something over to there, we just want to like increment it every time. Yeah. Oh, so okay, so T0 is how many elements you got, A2 is how many elements you want. Oh, okay. Right, because yeah, under all of this is this like uncertainty about yeah, the fact that we don't like exactly know. Oh, this is like one of the things I love about Odin and Zig is that like you're always aware all the time of like how many bits everything is. Like you don't, there's no like you underscore size. It's like that doesn't happen. Kind of. It's okay. Yeah, so I guess I'm kind of, I'm almost confused that like the count isn't. No, I'm still okay. Okay, so we could take n here as some quite large number, and yeah. Okay, and then we're just like decrementing it by this, yeah, what we got, like the T0 each time. Okay. Yeah, and then so likewise with the A1. Like yeah, the A1 is pointing to like the things that we want to load, and so you just have to like load things from the A1 like as many times as you need to like span the entire memory, and that's just going to be yeah, that's just going to be kind of like n divided by the T0. Okay. Yeah, I get those now, and then that's fine. And then what's this one here? This final one is bumping A3. Right, since if we're copying all of this to the destination. Okay. Yeah, I now get what's happening. Yeah, if this vector is like this kind of width that there's like some uncertainty about, we're just saying like copy the vector's worth of it, like yeah, well like yeah, okay, I get this. Okay. Okay, with that I probably should be able to just read what's going on here then. Now knowing all of that, so alright. Okay, so here we're saying everything is 32 bits. Set that like that. Multiply by the factor of 8. A2 here is this width. And then, which is like the n in the previous examples, and then the S4 is okay, what was this again? The result of this calculation. Okay, the calculation's done. S4 gets filled up with the kind of like the size, and then yeah, here we're saying yeah, argument number 5, which is the color, move this just into V8. Okay. I guess that's all it is. And then load immediate. Okay, just like wipe out A7. And then loop stuff. Yeah, A0 is like the very first, the beginning of like the color buffer we want to, the part of the color buffer we actually want to modify. And yeah, A2 is the width. Okay. I guess so we're kind of saving A2 here. If we're going to like decrement it, we want to save it back. Okay. Then I think maybe S3 is just temporary. And then for this rectangle, okay. So we say like some notes. Yeah, depending on the machine, the result will be different. Yeah, it's 256-bit vectors versus 512 versus 1024. Yeah. Yeah, you know exactly the bit width of everything. You don't know how many elements your vector can hold. Okay. This is the part I was confused about. You don't know how many elements your vector can hold. Oh. But like why? Like why is there uncertainty with regards to that? Oh, I guess just if you're using these like general purpose vector registers, but you might want to do something with like 4 bytes in one vector and like 8 bytes in another, and so kind of like instead of like creating some ISA where you have heaps of like where you have like separate things like depending on like the width of your vectors, it makes sense just to have some general things, but you need to general things which like you have to tell for like for the next sequence of vector operations, the vectors are of this size. Okay, yeah, I think this is a pretty like sensible design. I think it's easy to understand, and yeah, okay, this kind of works. Yeah, and some nodes, yeah, it's so the code can auto scale. Yeah, the old ways that AMD exactly. Yeah, we want to avoid the disaster that is x86, and to a certain extent AMD, where you just continue to add more instructions. Yeah, no, we don't want that. Yeah, okay, this is good. I get triggered so hard by x86. It's like people like it's the less said about it the better. Okay. Okay. So then here's like the big loop part of it. So now we're saying, okay, set the vector stuff again. Still have multiplied by I8. Still have 32 bits, and now we're using S3, which we saved above to be A2, which is just like the width. And then S4, okay, save the result in S4, fine. VSE. what's the SE again? I think I need to just look up the SE in the general one again. Like S should be like store maybe. Space SE. Or not. What's the SE? SE dot unit stride loads and stores. Okay. Okay, so this actually is like a kind of separate instruction, but like somewhat manageable. Okay. Right, byte, is it like half word, something, SEW. What is the SEW? Oh, the SEW is the thing that we set when you call, it's now like coming together. The thing that we call when we do the okay. Okay. Great. So okay. Okay, so it's, yeah, we wouldn't be able to do the VSE without the vset VLI beforehand, and what actually is it doing again? So it's just a store. Store data, RS1 base address, VM is mask encoding. Okay. Yeah, it's 32-bit because, yeah, we caught it with E32, yeah, okay. And then, yeah, and then since S32 is holding a copy of the pointer, of like, the point of the color buffer, right, here we're actually, this is where we're actually like writing bytes, like determining the color now, and V8 is the color vector that we copied from A4. Great, okay. Okay, this is cool. I am gonna like completely understand, it's good. And then, okay, and then now we need to do the, like the moving the pointer thing. So, since the pointer's S, since the total length is the S4, we're subtracting from this, like the width. Okay. Why? Because like in my mind, like the width is some huge number that's larger than these. Why would this work? And then, yeah, this is like the shift logical left intermediate by 4. So just multiply S4 by 4. And S4 is... S4 is like the thing we said at the beginning. Why? Okay, this one we're just increasing the pointer by S4. Okay. But I'm not sure why we needed to multiply S4 by 4 before we did that. Oh, I guess like since S4 is getting, okay, yeah, that's right. Like my confusion was like at some stage we're going to be multiplying this by like 128 or so, like 1028 and like or 24, and like things are broken then. So, but we set this every loop, so it's fine. Okay. Yeah. Okay, now I get that. And then we want to continue setting things to be the color, so long as we haven't done the entire line, and the entire line is S3, which is the width. Yeah, great. Okay. Okay, and then finally down here, well, by this stage we've done the entire line, and so now we want to jump to the next line to fill in the bytes. So, so yeah, why are we increasing A0 by the stride here? Because yeah, the stride is just like the number of like color bytes in the entire line. Okay, and then this means when we jump back up to the loop, that becomes the new area. Okay, great. Okay, cool. Okay, I understand now at least how this code is working. A lot more complicated than I thought it would be, but only complicated because it's been a long time since I've done anything with RISC-V, and I didn't do any vector stuff. Okay. So what is next? So yeah, so I should practice like drawing a disk or some other shape by writing some kind of assembly like this. Let me pick a like easy shape. I feel like a disk is the easiest thing to do. But it's like even then it's not trivial. Maybe a diamond, like, yeah, let's do something with a diagonal, like a diamond that's just like a square but rotated by pi on 4 around the center. Like that requires some thinking, but doesn't require any like quadratic math like a disk would. Yeah, I feel like the first RISC-V thing I do shouldn't be like, let's figure out how to like take square roots and stuff. No, we're gonna, well, we wouldn't have to do that since we could just like square stuff instead. Actually, maybe it's not too bad. Maybe a disk isn't bad. Maybe I'll do both. Okay, we'll start with the diamond and then we'll do a disk. Okay. How do I feel about copying this directly? Okay, let's copy all of this. Wait, I'm kind of shocked that there's no parentheses around this. I suppose this thing, like the double quotation mark, must mean like don't compile this, or like don't run it through the compiler, but just like run it through like an assembler compiler and just write this stuff out separately. Okay. We'll do both. Okay, and we want to copy this, Control C. Then I will, let's suspend this. Oh, okay, so yeah, here's a better workflow. Write the code in normal Brevis first using the pointer stuff. Then convert it to a normal RISC-V assembly, then finally convert it to vector. That sounds really sensible. I think that's what I should do. Yeah, I like this idea a lot. Oh, I should, okay, now there's like no long, I don't think I'll need to look at the RISC-V again, but not for a while. Let's write it in the normal Brevis first. Okay. Let's make a new project. Actually, let's like make a new directory. Okay, let's do make directory. Let's call it like RISC-V drawing experiments. And then I want to do like the directory copy. What's the best way to set this up? Sorry, Sal, it's been like 3 weeks or something, and I've already forgotten so many of these commands. So many of what's capable. Like if in this I want to set up a like the default Pong thing, and then I can start modifying that. Like how do I do that again? It's like I feel like there was some like tool, there was some command that you wrote that does do this. So kind of like I want to copy like the fulcra. Can I say like directory copy? Oh, what's like, there's a auto mod action needed. Like, oh, this is like, what are we doing? Where's like the Twitch dashboard? This always happens. It's so annoying. Oh, it's like, okay, it has been blocked, which is good. Okay. I'll just do like DCP. Okay, this can do directory copy, great. So I want to copy like the Pong into this. So let's do it was in the examples. Oh. Let's just copy the rectangle drawing example. You're going to do directory copy, yeah, rectangle drawing example into the thing that we now want to modify, the RISC-V drawing templates. Okay. And now, let's make a new file. Make file. Let's call it disk.lbc. Let's file copy the checkerboard over to the disk video. We need to give our program permission to write. Oh, what does it mean? It doesn't know what this is. File copy checkerboard into the disk. Yeah. And now we want to remove the checkerboard now. Okay. We want the delete, that's right. Likewise, let's rename in the productor the checkerboard. Make file disk.pd, and then we'll copy the checkerboard to the disk. And then we'll get rid of the checkerboard. Why did I even copy that over? I'm going to compile to it anyway. That was silly. Yeah, so now I want to compile it. So now I want to say, is it LBC? Oh yeah, how do we compile stuff again? I want to like give the compiler the directory which it's allowed to touch. Then I want to tell it the name of the file to think of, which is the disk.db. No, RBC. And then I need to give it permission to write to the disk.db here. Don't know the command lbc. Forget. What is this vector again? I could like look through the command history. Or did I even add it as a comment? I possibly did. In either case, new window, I think. Let's see, so let's move this into RISC-V drawing, the codecs. Let's open, this one here will be the compiler screen, and this will be the editor. So we want to open up, I'm going to go into the codecs and open up with writing permission the disk. CLB is the compiler, okay. So we want to say okay. Okay, and now if we go into the productor and the disk, we're gonna have to, I am gonna change the output of this to be not 180, so it's just quicker to view. But yeah, we can now start writing our workflow. So let's quit that. Okay. Program terminated. Okay, now for the writing code part. After we paste in and save the other stuff. So yeah, we should call this, we should begin to modify this. So I'll call this an ode, and yeah, so here, yeah, we want to write this in, the workflow Sam suggested is do it in Brevis, then write it in assembly, and then finally vectorize it. So let's say we call this like draw disk. Where, yeah, we have like when I eventually use, like, probably in the game, it would be good to just like draw, like, I don't know, probably in my game there will be like circles getting drawn, even if it's just like as evidence of like a tech demo thing. Eventually I'll need to like convert the X and the Y here to like the vector2 type that I added into the game last month. But for now we'll just keep it separate, but no time like the present to do like use vec2 instead. And then since this is a disk, wait, we're not doing the disk first. We're drawing a diamond. Since it's a simple diamond, it will just be a rotated square. We only need a single length. Ooh. I don't want to have to deal with multiplying or dividing things by the square root of 2. So, let's call this like diamond. Let's call this like the diameter. Then it's clear that like the diameter of any set is like the maximum. Take the supremum over the distances between all possible points. That's the version that's in my head. No need for the second argument. And then for the color, let's just keep it as is. I'm going to ignore all of this kind of sanitization to begin with. All of this is fine. It's all fine. So now we want to do not an ASM version. But let's keep this below as a reference. And we have to draw the actual thing now. So, so I think if we iterate through like, okay, this line we can actually copy. We do want to find the beginning. Yeah, I don't have to do this like calculation to find every pixel. So let's just say like, let's use this to find the center. We could say, a 64 diamond center, or like, it's like the pixel center pointer. What's a sensible name? Like diamond center pointer, that's fine. Or maybe just like center pointer, that kind of works. Center pointer, call it PTR. Okay. So yeah, how are we even going to calculate this? We just want to calculate this from the x and y and nothing else. So yeah, it's the same here. This gives us the x and y. So now we want to begin to like color this in different ways. Ooh, how should this get filled in? Like I think it's something where we just want to. We need to like increase the. We're gonna want to have just like 2 for loops, the outermost for loop is just controlling the height, as well as like the length of the inner for loop, and then the inner for loop is like constructing the like size of the diamond outwards and in. So loop time. Good thing I didn't delete this down here as a reference. Yes, we must remember to avoid creating the infinite loops. So yeah, before, yeah, like that's just, I programmed in this for hours now. Like it's, you don't have to be super careful. Yeah, so let's just say like, draw the diamond by a drawing but yeah, well, like what's a concise way of saying this? By just drawing like horizontal line segments that increase. So we need to first of all determine the pointer to like the top of the diamond. We can call it top pointer. Maybe there was actually no need to do like the center pointer. Yeah, I feel like there wasn't any need. Let's like first of all determine like the top coordinates. This is like a better strategy. So the top x value is just going to be x minus the half the diameter. Ooh. I don't want to do like floating point calculation things. No. We're going to avoid that by making this like the half diameter. Oh, I know the floating point calculation thing. It's not. It's fine. We'll just divide the diameter by 2. And like I don't think like it's like what if the diameter is 3? Then I guess it's like this itself is like an annoying thing to consider. Like in some sense, I want the diameter to be an odd number of pixels. Otherwise, it won't be like a perfect diamond. we can like sanitize that in some way. So we'll assume it's odd. when we divide it by 2, we lose like the 0.5, but that's fine for our purposes, since we want to kind of go up by once we've got the center coordinate, if it's odd anyway, we want to go up by exactly half of it. So the top x will be that. The top y will remain the same. And now we want to use this to calculate the center pointer. Well, that's just going to be the same calculation here, but with top x and top y instead. Okay, and then now we need to do the loop stuff. And this should be top pointer. The lag on this TV is not acceptable. I can I press a button and I can see the lag. It might be the capture card I have, because I'm not actually connected. Anyway. So let's draw half of the triangle first let's draw the top half of the triangle. I do want to, how should we do this? Will the compiler know to save diameter 2 as a separate variable or not? Maybe not. I'll say the radius. The radius is equal to the diameter divided by 2. And then in the loop, we want to set the j is equal to 0, and then provided the j is less than the radius. Add 1 to it at the end of this loop statement. And in the meantime, we want to draw our line. It would be foolish to call noob rectangle here, given we're going to convert it to assembly stuff anyway. Yeah, so we can just copy in the color at the position, and then we need to even figure out what the position is. Why is there a mosquito inside? S64. So we'll say line start. Line start pointer. And this is going to be the top pointer plus well, top pointer plus the frame width times 4 times like we just want to like skip through the number of bytes to get to the position. But then we want to subtract from that the so what do we want this to be? We want this to be j times the S64 frame width But we always want to be like and I think we just want this to be j, honestly, because yeah, each time we're just like going back diagonally 1, and so then we're multiplying this by 4, and then we want to fill in all of the bytes with the colors. So we need another loop. We can say DOM S64. So why am I using J here? Let's call this I. Set J to, well, yeah, J can be 0 here, this is fine. But we want to be checking here that J is less than 2 times I plus 1. And then we need to jump from the line start pointer to the appropriate place. Or I could even just dereference, kind of like add 2 things and then dereference them. I'll just say like pixel location. Pixel location is equal to the line start pointer plus 4 times j. And then here we want to say dereference this. What's the way of doing this again in this language? I guess I can just like call it with 0, but that feels a bit weird. No, it was with this. Dereference this here and set it equal to the color. And then in order to avoid an infinite loop, we want to got the macron on the A. We want to increment the J by the 1 each time. Okay, I think there's going to be compile errors, we all know this. The geometry may even be wrong as well. But I feel like that's all I need to at least make the top half of the diamond. Why did these get indented so heavily? I guess all of this stuff can go. This one. Okay, and then I should actually call this. I should call a draw diamond down here. So let's like get rid of all of this. And draw the diamond. Yeah, this mode 3 needs to change. I don't want to be like waiting super long for this. Where do we set that again? Here. We want to set this to mode 0. And let's draw this disk with light gray. All of this can go. I don't care about the key state. I'm not animating anything. Set up draw. Who cares about the keyboard events? I'm going to be quitting this program with Control-Alt-Delete anyway, and then cancelling it so we can... I don't need to quit it when the escape key is pressed. Get rid of that. Yeah, this looks fine, I think. So yeah, draw the background, then draw the diagram. Get rid of this. What's this like end the frame? Presumably we need that. Okay. So finally, we can call draw diagram with that stuff in here. Okay, draw diamond. Yeah, I feel like I'm going to leave. I feel like I've been streaming for quite a while already. I feel like once the diamond is drawn, I'm actually gonna like conclude the stream, and I need to get myself dinner, and there's some other stuff I need to do tonight as well. But this is a useful side tangent, and next stream we'll like lower this down to the assembly, or at least begin to do that. And then we'll do the same thing with the disk, and then once both of those, once I have experience doing that, we can start to add those to the game. But for the moment it will be the following. No, not dream. Let's like draw this diagram at like 200, 200 with a diameter of 100 and a color of light gray. And let's compile this. Or at least attempt to compile it. I should also okay, it failed. Does not know of anything called radius. Yeah, it's because I called it rad. A single time. Type mismatch. Right. See that? A mosquito flew past and I caught it with my fingers. It's now dead. A very different kind of bug. So yeah, we just want to make this like we want to type this as a 4-bit pointer. It's easy enough to fix. But this means that I need to consider these. Like I can do pointer arithmetic in this language, I think. I guess I just need to cast this as an N32 as well. Let's make sure the parentheses are correct. missing some. No. Yeah. Okay. Then this as well. This line start pointer. Need to cast this. Okay. Let's try compiling that. Oh, okay. It looks like it did. It is compiling. It passed. It's gonna be very satisfying to have Wi-Fi in the next release. And let's run this. It didn't crash immediately. That's good. Here's the reveal. What does it look like? Aha! Half a diamond. Kind of stretched, but the stretching is expected. Great. You know, like it's satisfying. Like sometimes you read all like the RISC-V code and you're like, I don't feel like I'm really you doubt your like competency, and then you like write all of this in one go and it works. So it's like, and then you're like, no, it's just sometimes you just don't know the vector specification for RISC-V. Okay. Good. So now let's fill in the other half of the diamond. And yeah, and then I'll call it a night. Like, I do want to do more, but I have to feed myself. But like, I wonder if there's like there's a more sensible way of doing this. Like, I feel like mathematically there should be a way that we can do the disk and this diamond at the same time, basically. Like with the diamond, what we want to just consider. Like, we just want to like consider like the sum of you just want to add like, you want to just add the absolute value of like x and y, and you kind of get that. Like, what would be more memory efficient? So like, using that method, you could just literally go through like every single pixel in the array, and you just go do the calculation, do the x and y calculation. If it's within the boundary, color it black. If it's without the boundary, color it like white. Zero branching would be going on. The code would be really easy to write. But a lot of writes would happen. Like exactly half more writes than in this case. But maybe that's actually not an issue. Yeah. So okay, the code is going to be like so much simpler. Let's just like there was. Like now I'm doubting if it is or not. Like intuitively it's easier, but we're still going to have to do this like start of the line pointer calculation. That's like, we're not getting rid of that. We will still need 2 loops. Maybe it's actually like the same complexity in some way. Yeah, it kind of feels like it is. We'll just continue doing this. But like, mathematically, one version is so much easier than the other. Okay, we're going to stick with this because in our game, if we are drawing a diamond somewhere, I don't want that diamond to like erase what's behind it, which the method I have in my brain would. But this is just an overlay, so it's fine. So we'll continue doing this. So draw the top half of the diamond by drawing horizontal lines and increasing the length. Instead of repeating this code, I kind of want to draw like, as we're like increasing the length of these things, just like drawing them at 2 separate locations. So for that, we want to also keep track of a bottom pointer, and then the copy paste, and then the bottom pointer will be, yeah, like this thing, but we're now wait, this top Y is clearly incorrect. I don't know. Like this entire thing is getting massively botched. The X is remaining the same. It's the Y that we get like the minus radius from. And then, yeah, the bottom pointer is just the line above, but with the string replacement. And then, you know, I swear programming is just writing words and then deleting them, whether seconds later or months later, or even years in the case of, like, I don't know if you're still on Sam, but like that thing you posted in the Discord where there was that code in the Linux kernel that was like 5 lines or something that did like nothing, that could have just been like done in 1 line. That was like, it was wild. But then again, the Linux kernel is huge, so no one reads it. Okay, so we need to change the line start pointer here to like the top line, yeah, almost like call it the upper. The upper line start pointer is this, and then the lower line start pointer is just going to be like the bottom pointer minus the it should just be the minus version of this. We're going back the number of I need to be careful here. Will I get some like mirror symmetry thing going on? Like we want to subtract the I times the frame width clearly. But I'm going to have to change like the negative I to a plus. Okay. Good thing my intuition was like, be careful. I did need to be. Okay, and then for the pixel location, we likewise have the upper pixel location, and then the lower pixel location. The upper line, the lower line, and basically everything is the same. And then we just want to set both of these to be the same. Okay. Let us try to compile this. And if it works, we'll make a backup of this and continue the streams later. Probably, like, it might be later in the week. Like, the amount of like company admin I'm doing is just so much at the moment. But I want to start applying the assembly stuff I learned today. Okay, almost working. Why is there this blank? Why is nothing getting written on the bottom line? I think it's because there should have been like a less than or equal to in our code. So let's deal with that. Why can't I see? Why can I barely see the screen? Oh my goodness. Elgato, what are you doing? What are you doing? This is almost unreadable. Completely unreadable. Okay, where's the software one error? So let's see, if the width is 3, the radius becomes 1. So in our for loop, we only do one thing. We don't want that. So we actually want this to be less than or equal to... yeah, we want to say radius plus 1. I think this should be okay now. But let's like change the position and the color of this song. Clean this up a bit while we're at it. What's the size of the frame again? It's 640 by, let's change this to mode 1. Like 640 by 180 by 480 is a bit too much. And now the center will be exactly 400 by 300. So let's center this. And also make sure there's not a bug with that. And then let's make this like, we'll make the diamond like a quarter of the size of the screen. So, we'll make it half the size of the screen. Okay. Compile. I should also name this diamond instead of disk. Aha! And it is a diamond. This is working. Great. So, you know, we can have more fun with this. Let's like have multiple diamonds inside each other. Will look cooler that way. Yeah, I'm not done tonight. Took us a while to get here. Let's not stop the fun prematurely. Not that that's ever happened to me in the past month. Yeah, that's like it didn't, like it was, I'm not going to talk about my sex life on stream. Needless to say, there was one session that lasted longer than 90 minutes. It was incredible. Anyway. So let's say, let's do, so yeah, so we want to have like lots of diamonds within each other. So, so we'll have like a for loop in here, a done loop in here. So we'll say draw lots of diamonds. And so we're not changing the center of each of these, but we will need to change the width, and we will need to change the color. So let's do dom variable. I guess nh. Let's keep everything S64s, since we're passing in the x64s anyway. We'll say I is equal to 0. And let's draw like 10 of them to begin with. We need to set the color. The color is 4 bytes. What's the type of this? It's just been N32. So we'll say N32. We'll set the color to be the light gray. However, let's just do like a modulus thing. I forget how modulus works in this language. It's like, is it potentially the question mark? We did this on like a different stream. I'm just going to look up the documentation. Let's do that now. What is like Brevis? smith.com. It's in here, I think. So we want to do, I think, what is the modulo? This is like, we'll do it. We'll just do it with. We'll do it with the more sensible option anyway, which is bitwise stuff. It's better this way. It's so handy though. If the compiler's competent, it's like, why not? So let's just say if when we AND this with 1, the result is equal to 0, we'll make the color black instead. Or we'll make it dark gray. Well, let me see what this looks like with dark gray as a background. And then we actually want to do the drawing the diamond part. However, we need to adjust the width. So we want to make this smaller each time. Let's just shrink it down almost all the way to 0, in which case we would want 10 times the I here. I need to think again. 40 times the I. Okay. This is so inefficient, but whatever. I should call this like diamonds.lbc anyway. Yeah, let's just kill the compiler. Oh, I don't get to do that. Let's go to the productor and make a file called diamonds.pb. Let's, before I forget about it, copy the disk into makefile diamonds.pb. File copy disk to diamonds. Of course it crashed because we didn't give it permissions. And now we can compile it in the proper way. So now I can say CLB in the codex, use diamonds, and compile that to the diamonds here. Always forgetting the file permission. No, this is like failing. Why? Because I didn't actually copy it to the right place. It was compiling an empty file, presumably. Wait, what's happening? Make file diamonds.lbc. File copy disk to diamonds. Compile. It's not LBC, CLB. The compiler has access to the codex. It's going to run diamonds. And it's going to write the produced instructions in diamonds.db. No, what? This is, why is this? Oh, I keep on forgetting this. I need the operating system to have a move function. Or having a copy function that doesn't require like file creation. It's so much easier that way. Okay. Let's launch the diamonds. What? Why can't I see anything? Have I think it's because I'm drawing yeah, why can't I see anything? This is not good. I think I'm drawing things in the wrong order. I'm drawing too many things. I'm skeptical of that. Okay, we do want to exit this. So let's open up diamonds again and get this stuff drawing in the correct order. There's kind of a bug in my code anyway, in that this light gray should be color. Let's say we just draw like 3 of them. Like, part of me is wondering if like if it's not rendering the frame because it's like doing too much. But you know, I doubt it. It was, the previous version was drawing a diamond just fine. Nothing's happening here. This is really weird. Yeah, what went wrong? What has gone wrong? Like, let's just do this in like the really basic way, without a loop at all, actually. Let's comment all of this stuff. Like that, it's like 300. I have more emails to write tonight. Yay. But no, this has been satisfying. It will be satisfying when I can. Okay, it's working. Now I can actually see the light gray as well. So now I am starting to suspect that something, like, what was up? Why was it just completely black before? Did I do something? Oh, was it another like infinite loop? Oh my goodness. There it was, there it is. It's always the case, always the case. The newbie error. The biggest noob error in programming is to make a loop that is an infinite loop. Sorry, prolata. Macrons on every vowel. Prolata. I should have known. Should have known. Should have known that was what was going on. Okay, so now we can do like the draw 10 of these. Okay. Let's compile this. And we'll save it. I can post it to the Discord, and then next time we can do other things. Do other things. Aha, great. That is what it should have been the entire time. Okay, next up is rotating this. Just kidding. Okay, I'm happy with that. So, like, I kind of want to animate it now. Like, wouldn't this look better if it animated? Like, we are evaluating this every frame anyway. Like, wouldn't it be cool if these like grew out constantly? Now I'm saying it out loud. We kind of have to do this. How would this happen? We simply would want to grow the diameter should be something that is growing. But then I have to sync that up to the time, which wouldn't be hard since we're doing this once per frame anyway. But then we need to do like modular. Well, like we'd be modifying so much of the screen. Oh, okay, here's an easier option. Instead of growing everything outwards, we grow everything in. And then that way we're not like, the frame rate, I don't think it will plummet. Okay, so if we were doing this, then all we need to do is keep the, yeah, let's get this animated. Yeah, once it's animated, we can like post the source, share it around. It will be fun. I kind of want to like post the source when I actually have like the inline assembly. I'm not going to post some like crappy version. So the 400 here is something that it's the 400 minus this thing here. We need to have this on the loop. We'll call this frame counter, and let's see. We just want to have this like looping between 0 and 40. Let's do this properly. Let's say we have something like diamond spacing. and we'll make this 40. And then we want to have our which itself is not ever going to change. And then we want to have our like frame counter. Keep this at 0. And then, we want this to persist across the block. So actually, it should be up here. And then every time we simply want to do the frame counter +1. And then if the frame counter is greater than or equal, like that's right, if it's greater than or equal to the diamond spacing, then set it to equal 0. Oh, I hate using a QWERTY keyboard. It's so bad. It's so bad. Okay, the frame counter is then 0. And then we want to include this in the calculation. So now we want to say draw diamond where the width is now 400 minus this, and let's like if we want it to be shrinking inwards, we want to be subtracting from this the frame counter. Yeah, and this, okay. I think this is all that's needed. Famous last words. Okay, let's see what this looks like. Oh, now we can see the frame rate. The frame rate is very slow. This is too slow. Way too slow. Okay, the easy way to increase the frame. Oh yeah, I don't like the way that pops either. Oh, I guess in order to like stop it popping, we actually want like, we want it to go through like 2 cycles before it resets. Okay, let's actually just change that. And while we're at it, we may as well reduce the size of the screen before we start doing our like optimization. Well, we'll do the optimization next time. But just to like get it working more now. Like, there's probably a better way of constructing this anyway. Like I might end up just because I want to see it like animating quickly because it will look cool. Next time we might modify this just to like draw like the hollow diamond, and then we can actually get this thing animating at like a much faster rate. I think. Like, I feel confident it would. Let's reduce the resolution from 800 by 600 to something lower. This will require the centers of the diamond changing. To what? 320, 240. So let's just make this 240 then. And like the minus 40 here is meant to be the diamond width. So let's adjust the diamond width to the diamond spacing. Let's see, we could probably just make this 24. But if I want to make this faster for the moment, let's do like, I guess we kind of do need to leave it. What if we did like 5? This might also mean I don't need to like modify the logic. Let's see, I think that would work. We'll see. We'll see how much faster this is. Okay, better, but there's still like the weird flicking issue. Yeah, I feel that like with a hollow version of this triangle, it will become a lot smoother. Like what even is the frame right now? It feels like it's like 6 frames a second or maybe 5. In some sense, like the amount that we're drawing is like O squared, but we could make it yeah, we can massively reduce the complexity by drawing the hollow triangle version, hollow diamond version. But I guess I will need to adjust, like, have to do like the 2 thing. But I also kind of want like like I can adjust this so that at least like the center doesn't like pop in, but like a white border is still gonna like pop in every now and again. Instead of like coming out of the background. Anyway, now my capture card can't handle it. Okay. So yeah, just reset it. Because now like negative things are appearing. Now I kind of have to do this like address sanitization. I think there is like I think the way to do this is to like just declare that if the width is like negative, make the width 0. Okay. Phone call will be answered later. Where's the draw diamond? So yeah, we can just say if C diameter is less than 0, make the diameter 0. Oh, but I can't modify it. Surely I can divide negative numbers by 2. Okay. Okay. Let's try and compile this. Like, yeah, it might be fun even for like the tech demo just to have like the like this diamond animation, even if for our game like it's unnecessary. Yeah, okay, this is good. This is enough for me tonight. So yeah, I am going to yeah, I kind of want to think about how to like do the proper version of this animation where the outer diamond doesn't just like pop in, but kind of grows so it's slowly. It won't be that hard. It'll be fairly easy. And I think actually like for this one, this would be a way to do it. And like in like the mathematical way, because yeah, like in some sense you just, each of these colors is just determined by the range that the absolute value of x plus y lands in. It's still, you still have to deal with all the pointer stuff. That's annoying. Maybe from like the cache coherency point of view, it's also, I mean, if the RISC-V controller even has a cache, I have no idea now. Maybe it doesn't. Anyway, yeah, I'm gonna call it a night. So yeah, let's back this stuff up, and then actually it will take a while for me to back it up, so I'll do that off stream. I forgot to do that ahead of time. But yeah, I should probably order from Framework like the micro SD card reader, and then I can just be sure I always have that with me instead of like having to look for it now. Yeah, thanks everyone who dropped by. This was fun. It's good to, you know, these current diamonds aren't exactly working in assembly yet, not exactly working in RISC-V. Maybe the title of my stream was aligned this way, but earlier on we did read that, and I'm now capable of adapting the RISC-V procedures to kind of do a more efficient version of this, and to get that going. And I'll be curious to see like what the upper limit of the frames could be. Like I wonder if with, yeah, like I'm wondering how smooth this can be. Something to determine next time. But yeah, otherwise, happy programming everyone, and yeah, see you later. Bye.